Hello everyone. This video is for people in the EE1630 module who want to understand Thevenin's theorem, and I'm making this video because the way Joe explained it was very confusing. Like, because I went into the lecture actually knowing how to do it. Everything she said just looked like really confusing, and I wanna show you how to do it a much easier way, and yeah, that's just why I'm making this video. So before I start, I just want to say I note things differently. So I have ISC, VOC, which she writes as VTH, and I also use REQ instead of RTH. You'll see why in a minute when I start doing the calculations. So the first thing you're gonna want to do is find ISC here, and the way I find ISC is if you imagine. Oh yeah, I forgot to draw the terminals here. If you imagine you're short-circuiting between these terminals, so you draw a wire, and this basically cuts out everything here, but it also cuts out here, so you could essentially draw the same thing here. And if you've shorted out a circuit like this, I hope that makes sense, then this resistor just gets ignored, this just gets ignored. So let me just erase that. So you can essentially see the circuit as this, because it's going straight, it's going from here, and then it's going down, and then it's going to go straight back to the battery. So there's going to be 9 volts, 3 ohms, and I'm sure you know how to use Ohm's law. ISC, I'm calling this one R1 and this one R2. ISC equals to VS, which would be 9 volts, over R1 equals 9 volts over 3 ohms. That's going to equal to 3 amps. And then with the let's just erase this. With VOC, imagine that imagine this just isn't here, and this isn't here. This is your VOC, because here's your terminals. VOC is open circuit, it means open circuit voltage, and you'll see why this matters as well in a minute. So Joe uses loop method to find this for some odd reason. I don't know why you would ever do that. You can literally just use the potential divider equation. I'm just gonna draw a quick equivalent circuit. So you can find this voltage by using I'm going to call this V out. Actually, no, it's VOC. Sorry, VOC. You can see it. You can see this is the same circuit as that. So VOC equals to VS times R2 over R1 plus R2. And you've probably seen this in physics A level if you did that. So that's going to be 9 volts. That's 33 ohms. I forgot to do the values. There you go. It's going to be 9 volts times 6 over 3 plus 6. So by observation you can see that it's going to be 9 times 6 over 9. And then these cancel out, so you're equal to 6 volts. So now you've got VOC and ISC over here. Now Thevenin's theorem, she doesn't actually say this explicitly for some reason, but the actual theorem itself is that Req equals to VOC over ISC. And we've got both of these values. We've got VOC here, we've got ISC here. So we've got 6 volts over 3 amps equals to 2 ohms. So, and then now you've got everything you need to draw the equivalent circuit. So you draw it like this. So you have, the way I draw it is just like this, but it can be a cell or whatever, it doesn't really matter. So you draw your VOC here, which is 6 volts, and then you draw your equivalent resistor, which is 2 ohms, and then you just draw your load. I usually draw it as a dotted line because it can be anything. It could be there. It doesn't have to be there. You know. And then that's this is just the equivalent circuit here. That's just all it is. And yeah, the reason I draw it like this is it makes it a lot easier to remember what VTH is, because V open circuit, like if you just imagine it opened up, I think the way I had it drawn was like this. If you just imagine it open, like without this, that's open, and then ISC will be it shorted, which will ignore this resistor, and then all you have to do is find the current in this resistor. If you see what I mean, right? So yeah, that's all I wanted to explain. And if you got any questions, leave them in the comments, and I'll answer them. Thanks for watching.